So this is an exponential equation requiring you to equate the bases to the power of 2 in this case, so we can solve for the value of x. So if you haven't seen this question before, it's an index equation question. It doesn't necessarily require you to use logarithms. You can if you want to, but in this video, I'll be teaching you the way to solve it via index laws. And how we firstly do this is by equating the bases, so then we can make 8, we can represent 8 as a power of 2. And if you know your index laws, 8 equals 2 to the power of 3. So we can rewrite that as 2 to the power of 3 to the power of x. So you see, I haven't multiplied this by x here because I want to show you that we can multiply it after to represent that as 2 to the power of 3x. So as you can see, we have 2 to the power of 3x and we have 2 to the power of 56. So to make 4 to the power of 26 as a power of 2, we need to first make 4. We need to first separate the 4 to the power of 1 from 4 to the power of 26. And how we do that is by rewriting 4 as a power of 2. And we can rewrite that as 2 to the power of 2. 2 to the power of 2 to the power of 26 is the same as 2 to the power of 52. So essentially we're writing 2 to the power of 56 minus 2 to the power of 52 over 30. And if you see this question right now, what we can do is that we can factorize the powers of 2 with the highest common factor, in this case being 2 to the power of 52 bracket 2 to the power of 4 minus 1, because 1, if you multiply, 1 goes into 2 and 2 to the power of 52. So the reason why I'm doing this is because we can't rewrite 30 as a power of 2. And that would make it really complicated. But what we can do necessarily is that we can factorize the indexes that we have to be able to represent this as a power of 2 by manipulating our indices. So if you know your index laws, you also know that 2 to the power of 4 is 16, and 16 minus 1 equals 15. And the reason why I'm doing this is because you'll see right now 2 to the power of 3x equals 2 to the power of 52 multiplied by 15 over 30. So what we can do is that we can rewrite 15 over 30 as a half, because we know that 15 over 30 equals 1/2. And a half, if you know your index laws, is 2 to the power of minus 1. So we can essentially rewrite this again as 2 to the power of 3x equals 2 to the power of 52 times 2 to the power of minus 1. And if we simplify this, we can say 2 to the power of 3x equals 2 to the power of 51. And then we can solve this as we equated the bases as a normal algebraic equation. 3x equals 51. We divide both sides by 3, and I don't know that on top of my head, but if I get a calculator, it's 17. So x equals 17. And yeah, so the value of x equals 17. So it didn't really require that much understanding of indices, only the fact that the hard bit I see is the factorizing bit. Because many students wouldn't have seen that. But other than that, it's pretty much index logic. And yeah, so thank you guys for watching.